us deal with the next looping structure or the iterative structure called as for loop. One of the most important looping structures of C language. Almost every program which uses iteration can be done using a for loop. Before we proceed with the operation of the for loop, let's look at the syntax and the cases where your for loop will be a must or where a for loop can be a replacement for while or do while. Let's first look at the syntax of this particular for loop. So I'll put the syntax for you. Now, before we say about this particular syntax, let's consider why a for loop is most popularly used or most regularly used looping structure as compared to while and do while. If I take an example of while, before I explain this particular syntax of for, let me use this. Suppose if I have a while loop, if I want to print this particular state value of I, say for 10 times, then what I'll do is, first I'll initialize the value of I with 1. Then I'll write a proper condition as I less than equals to 10. And then I'll write a statement called as printf %d, comma I, and I'll say I plus plus. Now, in this case, I have some instructions within a loop, some instructions before the loop, which will actually make the loop to work properly. Now, what are those instructions? The very first instruction is the initialization I equals to 1. Now, concentrate on those things which are highlighted with this particular color. I equals to 1 is the first instruction, which says that this loop is controlled by a variable called as I, which should be initialized with some value. Then the second important concept of a loop is this condition. I'm supposed to place a condition so that this will work for some finite times. And after that, I'm supposed to say increment expression so that your loop variable, that is a loop control variable I, is taken from 1 to 10 in steps of 1. So I have an expression called as I equals to 1. I have a condition called as I less than equals to 10, and I have an increment expression I plus plus, which will make this particular I to reach from 1 to 10. Here, the three expressions which are used with the while loop, they are scattered around the loop. Some instructions appear with the keyword while, some instructions appear before while, and some instructions appear within while. But these are the three important components which will make the loop to work satisfactorily or to make the loop to work as per the application needs. Rather than making these instructions scattered around the loop, why don't we merge all these three important components for the working of the loop at one place itself? While doesn't permit us to put all the three at one place, do while doesn't permit us to put all the three at one place. But definitely a for will help us to make all these three things to appear at one place itself. Let us see how we are going to associate these three expressions. So what I can do is, I can write a for with I equals to 1 as the expression 1, which I have quoted at this place, I less than equal to 10 as E2, and I plus plus as E3. A for loop helps us to merge all the three expressions at one place, and syntactically it says that I'm supposed to place a semicolon before and after these expressions. So I'm supposed to place an expression not before but after even, with E2 before and after, and with E3 I'm supposed to just place it before. So basically a for keyword should start with for, then a pair of round brackets. Within that I can have three expressions, E1, E2, E3. E1, E2, E3 are separated by semicolons at this place, and you can have n number of statements within this particular bracket which are supposed to be used for repetition, and then I'm supposed to identify the remaining program as statement X. So here your E1 is generally a initialization expression, your E2 is a condition, and your E3 is a increment / decrement expression. So for loop is basically associated with three expressions, E1, E2, E3. E1 more oftenly initialization, E2 a condition, and E3 an increment decrement expression. Now I have three expressions with the for loop, but out of these three expressions, which expression will work properly? Which of these expressions will work during what execution? Now let's understand the working of this particular loop. When the for loop starts with the expression even. Follow these arrows carefully. The arrow indicates the flow of the program with the for loop. It says start with the expression even. Once even is done, then go to E2. So E2 is supposed to be condition. Now when I say condition, a condition is either identified as true or either identified as false. If the condition is found to be true, it says execute all the instructions which are there in this particular body one by one. I'm saying this with respect to the condition as true. So when the condition is true, execute all the statements which are within this, so one by one, and then go back and execute E3. So it means that when I completed the first execution, E3 was not in picture. It was only expression 1 and expression 2. So when you start the second execution of the loop, it should start with E3. So go to E3 and after performing E3, again go back to E2. Again, if you find E2 as true, again execute the statements and then come back to E3. So now you're stuck up on this particular close path. Follow these arrows carefully. If you follow the syntax carefully, you'll find that E3 is not there in picture when the loop executes for the first time. When the loop executes for the second time, third time, fourth time, and so on, it will be always a third expression E3 followed by E2. Even will not be in frame for the remaining execution except the first one. So this process keeps on repeating E2 statements E3, E2 statements E3 until the condition remains true. At some point of time, the condition might turn out as false. When the condition turns out as false, it will automatically quit and rejoin at statement X. So this is my start point. With start, I started with even and then I went to E2. Follow the arrows carefully. A for loop always starts with even, then go to E2 and then execute the statements and then go back and rejoin E3. After E3, come back and check E2. Again, execute the statements if E2 is found to be true. When you find that E2 is false, you don't execute any of these instructions. Quit the entire body and go back to this particular statement X, that is the remaining program. So here, your even is an initialization, your E2 is a condition, E3 is increment decrement expression. Now, let's try and work with the same while loop with this particular for loop. So you said I equal to 1 as an initialization. So I'll say for I equals to 1. I'll place a semicolon. I less than equal to 10 is a condition. I'll say I less than equal to 10, semicolon. I plus plus is one more expression. I'll say I plus plus. And then you associate the statements which are there in this particular part. Since this has been identified as E3, so I'll say printf %d comma r and then this particular body. There might be some program which might be lying even after this. So if you now execute this particular for loop, you'll be able to identify the exact execution of this particular for loop. So this is how the loop executes. I equals to 1. Then the control goes to I less than equals 10. The value of I is what? 1. 1 less than equal to 10. True. True in the sense, go inside. Go inside this particular for loop and then go back and execute I plus plus. So when I changes its value, I is 2. So 2 less than equal to 10. Again true. Print the value of I and then go back. So here, if I write the output, it prints 1, then it prints 2, then it prints 3 and so on. At one point of time, it will print 9. So when I say print 9, it means that I am at this printf. Go back and say I plus plus. So I will now become 10. 10 less than equal to 10. True. True. It means that I'm supposed to print the value of I. That is print 10. Now, check this. When you go back, I becomes 11. 11 less than equal to 10. False. If this is false, we're going to quit this particular operation. So we're going to end up this particular operation and then continue this particular code. So while loop also prints the value from 1 to 10. A for loop also prints the value from 1 to 10. But the expressions which are scattered in a while loop are now arranged at one specific place with the keyword for, so that you can have all the 3 expressions segregated or assembled at one place itself, and a for loop works for all these 10 times. We'll look at the flowchart of this particular for loop. Let's look at the flowchart of this particular for loop. We said that a for loop will have only 2 expressions anytime being executed. So since E1 is a initialization expression, let's put a rectangle to indicate this E1. So I'll put an arrow to indicate start. So E1 is the first expression which is evaluated. After that, the control goes to what? E2. If you remember the syntax, the one which I have done previously, so after E1, the control goes to what? E2. So E2 is a condition. So let me put a rhombus for this. So when I say condition, a condition will have two outputs, true and false. So let me put E2 and place a question mark over here. If E2 is true, in that case, what it does is, it will now execute the statements which are there in this particular for loop. After executing these statements, what it does is, it will now make this particular control to go back to what expression? Yes, you remember it properly. So it was E3. So let me execute E3. Now, after executing E3, where the control goes back? The control goes back to what? E2. So I'll say expression as E2 in this case. Go back to this particular E2. If you identify in the first execution, it was only E1 and E2. Your E3 was not at all in picture. But when the loop executed for the second time, it started with expression E3, then went back to E2. Again, it executed the condition E2. If the E2 was found to be true, it executed the statements and then went to E3. It keeps on repeating these E3, E2 statements, E3, E2 statements, E3, E2 statements till your E2 remains true. At one point of time, you have to write a condition which will turn out as false. Then only it will be called as a finite looping. When E2 is false, it will automatically go out of the for loop and starts executing the remaining instruction, that is statement X. So generally, we say that a for loop assembles all the three expressions at one place, but at any given time, it will work with only two expressions. This is the basic flowchart symbol for the working of for loop. In some literatures, you will find one more unique symbol used for a for loop. A for loop being used in this fashion. A for loop will have three expressions altogether. This is expression E1, this is expression E2, and this is expression E3. A for loop, as usual, starts with expression E1. So don't forget to drop this particular arrow at E1 itself. Don't drop this particular arrow anywhere on this particular box. No, since the loop starts with expression E1. So it starts with E1 and then the control goes to what? E2 automatically. So after E2, so E2 is either true or false. If it is true, it says execute all the statements and then go back and rejoin the for loop at E3. So it goes back to the for loop at E3 and after E3, the control goes back to what? E2. So if E2 is true, again the same block is repeated. If it is found as false, then it might go to statement X. So we are not worried about the remaining part of the program. We are worried about the flowchart which is used for the operation of this particular for loop. So here, this is my start point where the for loop works with E1 and then control goes to E2 and then it will be statements if E2 is true and statement X if it is false. If it is statements, then it will rejoin the for loop at E3 and restart the loop operations again by checking the condition as E2. This is one simple flowchart which is used for the explanation of this particular for loop. So in this section, we have seen the syntax, the example and the flowchart of this particular for loop. Now question comes, why a for loop is generally a replacement of all the examples which have been used and when to use this particular for loop. I've stated at the beginning of this particular video saying that you can assemble all the three expressions which are relevant for the major operation of the loop at one place. For that, the instructions, the number of lines of a program definitely keeps on reducing. So we can prefer a for loop for such cases. Now question comes, when to use a for and when to use a while loop or when to use a do while loop. Basically, you're supposed to first remember that when to use a loop and when not to use a loop. First of all, you should identify, am I supposed to repeat or just make a selection? If your answer comes as that I'm supposed to repeat a set of statements, then you will say that I'm going to use a loop that is for, while or do while. Whenever the question comes to repeat a set of instructions for some fixed number of times. Suppose if you say that I'm supposed to make these instructions to work automatically, say for 10 times, for 20 times, for n times. If my repetitions are supposed to be done for some fixed number of times, then it will be always a for loop. Suppose if I'm supposed to make a repetition of this particular looping instructions or a set of statements till a condition is going to be hit or till a condition is going to be reached, we'll not be able to identify how these instructions, when this condition is going to occur. If you are very much sure about the condition at what time it is going to occur, then a for loop is preferred. If you are unknown about the time when the condition is going to be true or false, if you are not aware of the number of times, in that case, go for while or do while. Now again, in while and do while, when to use while and when to use do while. It all depends upon whether you want to make a decision and then repeat, or whether you want to repeat and then make a decision. If you say that I'm supposed to first make a decision whether to continue or not to continue, and then I should repeat the instruction, then it is while. Because while is an entry control loop which makes the condition to be executed at the beginning of the loop. And if you're supposed to repeat a set of instructions and then make a condition to be tested, then it is always a do while loop. So do remember that you're supposed to repeat a set of instructions for a fixed number of times, then for is preferred. For a condition based operation, then while or do while. Suppose if I ask you to print a message called as welcome for 10 times, then obviously your for loop is going to be used. Because when I say 10 times, I can say printf welcome and I can say for I equals to 1, I less than equal to 10, I plus plus. So I can use this particular for loop and say printf welcome, and this will repeat for 10 times. Suppose if I say that I'm supposed to print the value of n till the user enters a negative value. I don't know when the user is going to enter a negative value. If we are not aware of the condition when it is supposed to be executed, or when the condition is supposed to be true or false, in that case you can go for while or do while. This is one simple scenario where I have explained the concepts of while, do while and for loop at this place. Right? So do remember the syntax, do remember the operation of this particular for loop, because that is the one which we will be using in our programs at the later stage. Thank you.